Hello guys, and welcome yet to another video for microcontroller technology. I want us to go through robotics programming. I hope this video will help you to understand more about robotics programming by knowing the basics, and also be able to answer some questions that you might be asked in some of your assessments in the exam level, that is the NEC exams. So if I go to my first slide, you discover that I have written some basic knowledges about robot programming, whereby I've said in robot programming various languages are used, such as the AML, the Rail, RPL, HELP, RIPL, and so on, to necessitate its functional use. These are just some various programming languages that an operator or a user designs in order to enable a robot to operate its function. So some of the basic commands used are, we have open, which enables the robot to open the robotic jaws, and here we are talking about a specific type or part of a robot, which is the gripper. Then you have close, which closes the gripper jaws. Then you have move, which enables the robot to move in either planes, either horizontally along the x-axis or vertically along the y-axis. So horizontally, it can be able to move from point A to B. Vertically, it can be able to lift an object from a resting position and take it up to maybe a shelf or a storage place that is on a raised part. Then you have start, which initiates the robot movement, and here we are talking about the muscles of the robot, which can be the actuators. Then you have stop, which makes the robot to stop after it has reached the destination it is supposed to stop, and maybe place an item the destination that it was carrying initially from its source. Then we have a very important point to note, whereby we say the movements are positive if it's on the positive side of the Cartesian plane, and negative on the negative side of the Cartesian plane. Every time the robot stops, it's assumed to be at coordinate 0, 0 of the Cartesian plane. So this is a very important point to note when you're doing robot programming, because a robot has to follow a designated path, so it will be making the movements based on the planes, either horizontally or vertically, and we'll have to look at the movements from its rest position when it's at a stop, which is considered always to be at coordinate 0, 0 of the Cartesian plane. So if it moves on the right, it is making a positive step. If it's moving on the left, it's also making a negative step. So the explanation of this knot can be further explained by this diagram here, whereby there is an illustration. We have a Cartesian plane having a y plane and an x-axis. The intersections of the y plane and the x-axis are at 0, 0. So we are saying that if a robot is at 0, 0 and is making a movement upwards, then it's making a positive movement. If it's making a movement downwards, it's a negative movement that is along the y plane. Then if it's making a movement to the right, it's a positive movement, and if it's making a movement to the left, it's a negative movement. So after you have understood the movements of the robot from its rest position, then you can be able to now write a code using these commands that have been put here, the basic commands. You can now design a program that can instruct a robot to make a movement from a source to the destination. So if you move to the next slide, there's an example whereby you have been asked, told that table 4 shows the commands of a robot programming language. Write a program to direct a robot to pick an object from location A and drop it at location B, following the path of the figure. There is a table here having a command and a description. The table here is just used as a guide on the programmer on which types of commands that he's supposed to use in order to enable that robot to move from one point to another. So this is just a guide. You'll find most of the questions have these guides, which means that when you're designing your program, then you have to include the commands that are present on this table and not any, or not add any from any external source. So there's a command here whereby we say open. It helps the robot to open the gripper jaws. We have closes the gripper jaws. Move, and if you look at the move command, it is in a coordinate form, a coordinate of a 0 of an x-axis, sorry, and a coordinate of a y-axis. So with the description, it says the robot will have to move horizontally x meters and vertically y meters relative to the present location. And the present location, if you look back at the note, it's what I was indicating at a rest position, which is 0, 0. Then you have a further explanation there. If it makes a negative x meters, then it's a negative horizontal, because it's making a movement along the horizontal axis, which is the x-axis. And if it's a negative y, then it's a negative vertical, which means it's making a negative movement along the y-axis. Then we have the start, which is a command that enables a robot to start moving by initiating the muscles of the robot, which can be actuators. Then we have the stop, which enables the robot to stop moving. And we have a command for end, that means it marks the end, or it marks the finish of the program. So after knowing that or interpreting that table, we now go to the path. So if you look at on my left, there's a picture there showing the path. So that was the path that was asked by the question, to now design a program that can use the commands that have been stipulated or mentioned in that table to make the robot move from point A to point B. So once you're given this question, you have to remember that note that I always said. It's like a robot, it's every time it stops, it is at 0, 0. So you have to make you have to make a conclusion on the movement from 0, 0. So if you want to start the program, the first command will be open. Open because it will allow the robot to open its gripper jaws so that it can be able to grasp that object and pick it or lift it up. Then after it has opened, it has to close to confirm that now it has grasped the object. After, the next command will be now to start, to initiate the movement. And once we start, the next command will be moving. So it will be move. And remember, the movement of a robot, if you look at this table, it's written XY. So it means you have also to indicate your movement of the robot in terms of a coordinate form, which is an XY. So if you look at the 10 meters, it is affecting the Y plane, which is our Y axis, and we are moving downwards. And always mark that note where I said anytime a robot is at stationary point, it's assumed to be 0, 0. So it's moving from point 0 downwards. If you go to that Cartesian, back to that Cartesian point, if I go back, if it's at 0, 0 and it's moving downwards, it's making a negative movement along the Y plane. So it means my Y plane is the one that is being interfered with, or is being affected, but my X axis it's remaining 0. So I'll write in coordinate form move in brackets 0 because my X axis is not affected, comma -10 because it's making a -10 meters from its rest position downwards. So after it has made that 10 meters downwards, it will stop. After stopping, it has to start again and now move. If you look at the 20 meters, it is along the horizontal plane, and if it's at my rest position, I'm moving to my right, which means the robot is making a positive movement based on this Cartesian plane. If I'm at 0, 0 and I'm moving to the right side of my x-plane, then I'm making a positive movement. So it means when I'm writing the coordinates, I'll say move in brackets, 20, 0, because my y-axis is not affected. It's only the x-axis that has been affected. After covering that 20 meters, I have to move again 15 meters downwards. So the robot returns back to its default, which is at 0, 0, and I have to move 15 meters downwards. So from my point 0, 0 going downwards, my x-axis is not affected, so my x-axis remains constant 0, then comma, my y-axis will be negative 15, because it's moving from 0, it's moving to the negative side of the plane, the x-plane. After that, it will have to stop and start again, and now move. If you look at my 25 meters, is moving towards my left from the point 0, 0 at stationary, so which means it's making a negative movement. So it will be move negative 25, 0, because my y-axis is not interfered. It will stop again and start. Then I have to move 5 meters again downwards. So if I remember the Cartesian plane, if I'm moving downwards from my 0, 0 plane, that is at stationary, then I'm covering a negative distance. So it means my x-axis is not interfered, my y-plane is the one being interfered. So I'll move 0, negative 5. I stop again. The robot will stop and start. After starting, it has to move 7 meters, which is to my right. So it means that the 7 meters, it's a positive movement based on that stationary point. So I'll move 7 because the x-axis is the one that is being affected, but my y-axis remains 0. Then it stops. After stopping, it opens the gripper jaw. Then the program ends. Once it has opened, it means it has placed that object at point B. So that is how we write the program for that question. So that was an example, an example question of the robot programming. So if we move to the next, there's another example where it's written table 6A shows the commands of a robot programming language, while table 6B is a program to control the movement of a robot. Draw a trace table, to show the robot path, indicating the distance. So I've also been given the same diagram, the same table that contains the descriptions on the various commands on the specific commands that are to be used when designing that path, whereby we have said open opens the gripper jaw, close it closes the gripper jaw. You have move in coordinate form x, y, moving the robot x and vertically y meters relative to the present location. Always remember that the present location is always at 0, 0 every time a robot stops. It can either make a negative distance along the x horizontal axis, or the negative horizontal, or it can also make a negative vertical distance based on the present location. Then we have a start, robot starts to move. We have a stop, robot stops moving, and we have an end. So this is an inverse of the first question, whereby here we have been given a program. They now want you to design a trace table or a trace path to show how the robot is moving along the path. So this is another set of questions that you can be asked on robot programming. So into my next, if you look at the right side that I've written in blue is the program. Then on my right, the right hand side is the trace path of the robot. So the program was open, close, start, then move 20, 0. So you'll always remind yourself first of the coordinates. If you are at 0, 0 and you're moving a positive distance along the x-axis, then it means you're moving to my right, because I'm making positive steps. So that movement, if my object is at A, then I'll have to move 20 meters to my right, because that is a positive distance and it is affecting the horizontal, which is our x-axis. So it will be moved 20 0. If you look at the diagram where the object is, I've moved to my right 20 meters, then it will stop, start again. They have said move 0, negative 15, which means the x-axis is not being interfered or affected. It's only the y-axis that has been affected, such that it's moving downwards relative to the present location, because it's a negative distance in the y-axis. So when I'm making, after stopping, covering the 20 meters, the robot will have to move downwards 15 meters. Then it will stop and start again, move, in brackets 5, 0. So it means it's moving, the x-axis is the one that is being affected by moving 5 positive distance in meters, but my y-axis is at 0. So that tells you that the movement is to my right. After moving 5 distance meters, it will stop, start again, move 0, negative 10. So 0 means the x-axis it has not been interfered or affected. The y-axis, it has been affected by moving a negative distance relative to the present location, which is at coordinate 0, 0. So it will move downwards. After moving downwards 10 meters, there is a stop, start, move again, negative 25, 0. So it means that the negative 25, it is from the x-axis. So the x-axis is the one being interfered, and if it's a negative value relative to the present location, it has to move to the left, because moving to the left from point 0, 0, then it means you are making a negative movement. Then you have to stop, start again, move 0, negative 6. So 0, negative 6 means the x-axis, it has not been interfered, it's at 0. The y-axis is at negative 6. So it will move downwards, then it will stop, open, and end. So after that, it means that we have already reached our destination, which is at point B. And that's how you could have interpreted a program by now drawing a trace path of how the robot was moving based on the distances that you have been given here. And most of the time, this is not you are not supposed to be accurate, but just to show the variations. If you show the variations of the distances, then you are okay. Alternatively, if you want to be accurate, you can, since you cannot be able to draw the 20 meters on a piece of paper, you can convert using a scale and then draw the meters using a scale, or you can sketch, whereby maybe you can make some reasonable distances, 20 meters to be slightly shorter than 25 meters, and so on, just to show that variation when it comes to the movements. So that is another example of how you can do the programming and so on. We have another third example whereby figure 5 shows a path followed by a robot to move an object from point X to point Y. Write an algorithm to represent the robot motion. There's also the same table. If you look, the table is just the same because it is giving you the instruction. This is one of the very easiest maybe questions you can find in microcontroller, because you are told to write a program and you have been given the list of commands that you're just supposed to use when it comes to the questions. So it means that if I have my command which is open, I'll use open to open the gripper jaws every time, close to close the gripper jaws. The movement has to be in coordinate form by having an x and a y distance. The movement has to either be horizontally or vertically. I know at some point I'll either have to make a negative distance or a positive distance on both axes, which is the x-axis and the y-axis. At some point the robot will have to stop if it's making if it's following a path from the source to the destination. There's a time there's a point it will have to reach and stop, so I'll have to use a start and stop command. Then after finishing that, I'll have to end. So you have to here it was resembling almost the first question, whereby you've been given a trace path of a robot. Now you're told to write an algorithm. So that was the trace path, whereby it was 6 marks the robot at x, then that was the distances it has to move. So you have to always remember the first program or the first set of code is open, whereby the robot will open the gripper jaws to enable the grippers to now be able to grasp. After it has closed, after opening, we go to close, whereby the robot will close to make sure that it has grasped the object and lifted it up. So that you have to initiate the movement by using the command start. And if you look at the way I've used there, I've used start then at x. So my starting point is at x, then I'll have to move. If I'm looking at the movement is moving downwards, so it's moving along the y-axis. The x-axis it's not being affected, so I'll write move, and since the movement has to be in coordinate form, then it means it will be move in brackets 0, -5, because it's making a negative movement from coordinate or the center coordinate 0, 0, which is at its preset location or its initial location. Then you'll have to stop, start again, and if I look at my 25 from the diagram, it's on my right, so it's meaning that if it's at point 0, 0 and it's a coordinate, then it's making a positive movement. So I'll write move 25 because 25 it's affecting the x-axis, the y-axis it's not being affected, so I'll write 25, 0. After that it will have to stop and move 7 meters downwards, which is a negative distance based on that Cartesian plane. So I'll write move 0 because the x-axis is not affected, then comma -7, stop, start again, and then I have 30 meters, which is 30 meters, 8 is to the left, meaning it is covering a negative distance relative to its present location, which is at coordinate 0, 0. So I'll say start, comma, in brackets, sorry, -30, 0, then stop again and move. If it starts before moving, it starts, then moves in brackets 4 meters is moving downwards relative to the present location, which is at coordinate 0, 0. So I'll move 0, -4. The x-axis is not interfered, it's only the y-axis being interfered. I stop, the robot starts again. It has to move 6 meters to my right, which means it's a positive distance from coordinate 0, 0, which is at the center coordinate. So I'll say move 6, 0. Y is not interfered, so that's why it's a 0. Then it will have to stop. Now stopping, it is stopping at point Y. After stopping, it opens, whereby opening allows the robot to place that object at point Y. Then we have close, whereby it will close the gripper jaws, and then you end the program. So that is how that is how you can write a program of a robot following a designated path using the coordinate form to know that. So that is the end, and just as I've said, is in robotics, always just mark the commands that you use, and another important thing is to mark the sequence of the programs. That is where we confuse most of the times, and the sequence is always, if the robot is supposed to start, and if you look at this note here, If the robot is supposed to start from a one point to another by maybe lifting or taking an object from one point to another, then the sequence of the program should be it first has to open the gripper jaws. So that will be my first command. After opening, it will have to close. That is, it will close the gripper jaws to confirm that it has grasped the item and it has lifted. So it's very ready to now go to the next step. After closing, then the next command that comes there, it is to start, because we have to initiate the muscles of the robot so that they can be able to accept a movement. It's like we are initiating a movement. So before we go to move, we have to start. So I'm talking about the initial part of a program when writing. That's where we always confuse our times, and the ending part. So after starting, we now come to the move. Now when we are in the moving step, it's where we now look at the movement in terms of a coordinate, the XY coordinate. So that is the next command. Now there, the moving command is where now there is tricks. You have to know this movement, where is it going? Is it along the x-axis? And if it's along the x-axis, is it going to my right or is it going to my left? Is it a positive distance or is it a negative distance? So that is a question you have to ask yourself. After knowing that, it can also make a y or a vertical movement. So you have to also know that if it's making a vertical movement, is it going downwards relative to its present location, which I'm now terming it as a coordinate or a center coordinate 0, 0, or is it making a movement upwards relative to the present location? And that is where you have to really understand this x plane, the xy plane, whereby you know the positive distance. If it's along my x-axis, then it is making a positive distance when going to my right. If it's making a negative distance when going to my left. If it's along the y plane, then it means it's making a negative distance when going downwards, and it is making a positive distance when going upwards. After that, then you have to now, in between the movement, after it moves and it stops, the next step is to start. Then you move again. You write the movement in terms of the coordinates, you stop again, you start, you move. So that is how the sequence ends, until when you now see the final bit where the robot has arrived at the destination. So if it has arrived, you will say it has to stop. Then after stopping, it has to open. By opening the gripper jaws, it means it will have already placed that object that it was supposed to carry from the source at its destination, and then you end the program. So that is just some basic tricks, or the basic tricks that arise when it comes to robot programming. And I think and I hope that these examples, the 3 examples, can be able to shed some light to you when it comes to robotics programming. You can be able to understand at least, and do a lot of revisions on the same. And hope this video helps you also to understand more and more. Otherwise, for that case, I'll have to end it from there, and all the best in your academics.